I think you just need to make sure that when you join the link, you're signed in to your Zoom. Because I thought I didn't, but I was wrong and Ben was right. And I just needed to be signed into SSO in Zoom before opening the link.
I just SSO auth to Zoom to add a thing to a calendar. So I thought I was almost certainly added, but maybe it's a different something. Maybe my local client doesn't have a cookie. Oh.
Okay, are we ready?
Good.
Recording. Okay, so a couple things I went through on this section, which is where we said we wanted some examples. And so I came up with several with the help of Jesse and Josh and some other folks. And I ran into one that I think illustrates what might be a problem. So I wanted to talk about that, but I'll go over these first. Oh, and real quick, the other thing that I updated in here is the Stack platform directory. As I was writing that up, it seemed pretty straightforward, but I'll come back to it just in case. Okay, so for these examples, the first was the AnyMixin build pack, essentially like the apt build pack. This one's pretty straightforward. It passes if one of a mixin is required by the build pack, and I should probably say not provided by the stack, or a mixin is required by an app and not provided by the stack. And then it will be skipped if there's no mixins required. Oh, and I see that down here. A mixin required by build pack, but the stack provides it. Same thing for an app. For the next example was, again, this is kind of fictitious, but it's a Postgres Stackpack where it can provide libpq and also like a custom DB cert. So in this case, you might have like a Ruby app that requires the libpq mixin and the DB cert, in which case it would pass. But then a Java app that doesn't need libpq would just require the cert and it would still pass, but it wouldn't install the libpq package mixin. And then, oh yeah, this is just I don't know why it's Python, but it's an example where the stack already provides libpq and it's required, but it doesn't get installed. It would not pass if an app requires the libpq mixin, but not the cert, which seems okay. It would just skip and then not install anything. And then of course, neither of them. Now here's where it gets interesting. Josh, I don't know if he's on the call, but he had a good idea for a Chrome driver stack pack where it would install both Google Chrome stable mixin and then Chrome driver as like a non-mixin, just a regular dependency. And so this would pass if the app requires Chrome and the Chrome driver, so both. It would pass if it only requires Chrome driver, and it would pass if it requires Chrome driver and Chrome, but Chrome is provided by the stack. It'd skip when it requires Chrome, but not the Chrome driver. And then it would skip when neither are required. So what's interesting, and I think you may even already have this question in your head, is this case right here. Because there's a situation, and I call this out on line 204, where you can't have, or at least I don't see it yet, you can't have the Chrome driver dependency depend on the mixin. And so it makes it very possible or likely, I guess, that you'd end up in this state where detect would pass, the build might even pass, but then at runtime, you'd be missing Chrome because you didn't include it in your mixins. And that feels out of whack to me because depending on Chrome driver should imply that. So that's the one that I wanted to talk about.
Can the build pack, so the mixin was required by another build pack does not preclude the Chrome driver build pack from installing the mixin.
Right.
If that makes sense.
Right. But then it does, but then how does it differentiate if the stack already, should it just is the solution to just always install it, even if the stack already has it?
If something required, just to repeat the case, so there's a non-mixin Chrome driver and a mixin Google Chrome stable that's required by Chrome driver. And you want to make sure that anytime Chrome driver gets installed, Google Chrome stable is installed because it's required by Chrome driver. So you could have things that request the Google Chrome stable mixin without Chrome driver by itself, or you can't do that. Is that right?
Not with this build pack, yeah.
Right.
I mean, and maybe that's why this is just too fictitious. Maybe those are just two different build packs, you know?
Even if they're one build, sorry.
I'm sorry, was going to be like, is this an example of something installing Chrome driver that you would actually want to do with a Stackpack? Right? Is there any reason the regular build pack can't install Chrome driver?
Yes, I believe so, because I'm not, again, this maybe Jesse knows that, or Josh knows, but like we've had trouble with that in V2. I don't know if you guys have anything to add to that.
Yeah, I don't remember if Chrome driver needs to be installed. I mean, Chrome driver has to know a bit about how Google Chrome is installed, but I think if we're doing Google Chrome stable, then Chrome driver could be installed by a normal build pack, but I'm not sure. But even if it couldn't, you could have two Stackpacks, to your point earlier, right, Joe? If you had two distinct Stackpacks, then it could rely on Google Chrome stable, which would then resolve as we expect, I believe.
I guess this doesn't get into the questions we're trying to answer here as much, which is about the usage. But is this also like the kind of thing that is ABI compatible that you could change on a rebase, right?
Yeah, good question. Again, maybe this is like not a good example, and maybe the problem is not that you can't do this, but that this is not a good use case for a single Stackpack. So to your point, like, is it ABI compatible? Should this simply be decomposed into two Stackpacks?
I want to get right to the like problem you pointed out, which is the case where something requires Chrome driver and nothing requires Google Chrome stable. Why can't the Stackpack in that case just install Google Chrome stable anyways? Is it that we don't have a method of pushing forward to get the metadata to say that the mixin was installed and it'd be missing that metadata on the image? Because that could
I think the problem
right?
is that it could, right? So you can totally install it even if it's not requested. I think the problem I'm worried about, and maybe it's not a problem, is that something else already installed it, or the stack provided it, and then you either end up with, just bloat from it being installed twice, or potentially the wrong one on the path.
It's not in the build plan, right? It's not in the build plan, which means that you can now have branching logic on whether to install it. It's not only if it's in the build plan as a mix-in. Now and also I don't see it.
To me, all of this is, or the reason we haven't exposed the mixins inside of the container, the mixins that are already installed inside of the container, is because we're assuming it's possible for the Stackpack to tell when a mixin is already installed, or that if you run apt-get install and it's already installed, it will say, yep, it's installed. Sounds good.
Yeah, so it can just check the packages and see if it's there.
Or just install it. It won't install twice, right? It'll just be a no op change.
But wouldn't your default, if you were writing your own like apt build pack at first, just be to spin through the build plan that you were given? And then I guess at some point you'd realize that maybe there was some introduction of someone not requiring it, or I don't know. I could see where it would evolve into you writing a build pack one way, and then now you suddenly have to like rewrite that build plan based logic.
Many times a mixin is going to be, in most cases, a mixin is going to be required, and a lot more than that mixin is going to be installed, right? Because you'll ask for image magic, and image magic depends on 30 packages. And so apt-get install image magic will install, all of that, right? And so we definitely need a way for the build pack to report that those mixins were installed. But I thought that was in there through the reporting interface, or I forget what that interface looks like, but there's a way to do that for normal build plan entries. Have we, maybe this is sort of a separate question from, is it appropriate for the build pack to do that? But is there a way to report the mixins that actually got installed forward?
I feel like we do need that, right? Yeah. Eventually.
I'm not totally sure if they have to be reported as mixins, because once the build finishes, the mixin list itself actually doesn't have version numbers. It's not actually useful, right? Like we could just say there is no mixin list for the application, as long as there's a way for the whole dpkg thing to be dumped by the app build pack to say this is like as long as there's a place to capture that metadata. So like normally in the new version of the bill of materials thing, what does that look like? It's you put stuff in launch toml and build toml. I forget what that RFC did.
Or like your outgoing build materials entries, you put them in launch toml or build toml, depending on whether it was launch or build dependency.
And does that work for Stackpacks? I assume it does for normal entries. So does that work for mixin entries?
I'm not exactly sure what's in here, but I think we should do something a little bit special for mixin entries, or like maybe the output looks the same, but I would like for us to gather all those up into the mixin label at the end of export, if that makes sense. Like if I use a Stackpack to install a mixin on the run image and then export an image on top of that. And then later I want to rebase and the image I'm rebasing with already has the mixin. I feel like that should just work transparently without having to rerun the Stackpack. So I'd like to take Stackpack installed mixins and then end up putting them somewhere, put them with the rest of the mixins, right? Because that final app image has a label that says what mixins are there and it should be complete. And we could use that to our advantage later if we keep it complete.
Should we support rebasing with different base mixins? Because then you're performing a different operation on the rebase than you were the time you built the image.
Like we already let the mixins change so long as none of them have been removed, right? Which is why I want sort of the metadata for mixins and non-mixin things that were installed by Stackpacks on the app image to be distinguishable from each other. Because if the only thing that was installed is a mixin and we have a definition of a mixin, then we shouldn't have to reinstall it if it's already there on the run image at rebase.
Should you be able to remove a mixin for the base image if you have the app build pack? Because when you rebase, it'll now install that mixin on the rebase instead.
Yeah. I think that's the right thing to do, right? Otherwise, we're not trusting our mixins to really express the contract we thought they were.
Yeah, maybe. It's gonna make it's gonna make it hard to write an apt build pack because you have to figure out how to get a list of all the packages that you installed, not all the packages that are there, right? But just some number of packages that were installed in the previous run and extract that and put it somewhere. I guess we could say we'll accept all of them.
Just get the list first and then run apt install and then get the list again and calculate the diff.
Save the diff, yeah.
I mean, like base image will have some packages. You'll get some requires for mixins, and then you'll install maybe twice as many mixins as what the requires were because of dependent packages.
So before you do anything, you get the list of packages installed. Then you do your build pack thing and install 20 packages. And then you get the list again and you calculate the diff between the before and after.
Yeah, it's just what was a simple build pack.
No, I don't think app build pack was ever simple. Like my example is simple, but it's not really what we'd ship. I feel like that's just par for the course. That you have to do some stuff like that.
What happens if you don't do that? What if you just fail to output the mixins you installed in addition?
I don't think anything bad happens, it's just Emily doesn't get her data and then she's sad.
Well, if we build the rebase to check whether mixins need to be installed using that data, then something bad would happen on rebase because you wouldn't reinstall them, right? But I think that's probably the right thing to do. Like, it just makes sense coherently.
Why wouldn't you reinstall them?
Because my proposal is that basically there's implicit mixin requirement on rebase time, and that requirement is the diff between the app image and the run image.
So even if you have, let's say you depend on mixin foo, and it depends on mixin bar, and then in a future version of foo, well, I mean, maybe that's part of the compatibility. It no longer has that dependency. You would still install it.
Yeah, because we don't know. Like, you'd have to do a rebuild to get something with fewer dependencies.
Apt differentiates between explicitly installed things and not explicitly installed things, right? So if on the first build it gets foo and it doesn't get bar because bar just happens to be a dependency of foo that nobody requested specifically, and then on a subsequent build it gets foo and bar because foo and bar were both installed, that strikes me as risky. Apt is going to do slightly different things. It may install, there's a suggested, or there's some packages, some dependent packages that are only installed if you explicitly install something and are not installed if you don't explicitly install something. So I'd want to see.
Well, maybe we don't need bar to be in that list then, right? It's like, did you need foo or didn't you?
If you don't need bar to be in that list, then does that mean you shouldn't have to report that you installed bar?
Yes, because if you're missing foo and you have to go install it, you'll get bar. And if you have foo, you have bar.
So then we don't need to do the subtracting of the lists, right? Or like we don't need to report every mixin that got installed. We just need to report the explicit ones.
Yeah, I think that
makes this easier because that's, those ahead of time. The build pack doesn't actually have to report those.
Right? Yeah, that's already in the build plan, right? We're already reporting the explicitly required ones, except for in the case where you're dynamically installing one on your own, I guess.
So then we don't end up with a full list of all the packages installed on the mixin list of the generated app image.
But it does mean any stack pack could install any number of app packages that are technically mixins, but if it didn't request them as mixins from like an app one, then it can just do whatever it wants to the image, right? Which is that's kind of what we're talking about with the Chrome one, right? If Chrome driver Stackpack was responsible for installing Chrome stable itself, then there's no way for it to report that happened for downstream build packs.
Maybe that's okay.
I think that's probably okay. Because if you do need the reportability, then it would be up to the stack author to break those into two different build packs, and then you'd have reportability by requiring it explicitly.
Also, it should still be possible to generate that DPKG list of everything that got installed if you need it, right? Without going through the mixin interface, because you need things like versions also separately.
I think most people who want a DPKG list are going to want a DPKG list. They're not going to want to like translate our mixin label into a DPKG list and take it on face value.
Okay, so I'm gonna step back for a second. Like, this seems like an important discussion, but one of the things I'm taking away is that we have given this example of Chrome and Chrome driver. I think we have enough knobs and levers that this shouldn't be a problem, because this is probably a poor build pack design. I'm thinking at a minimum, maybe these are separate build packs or stack packs. Maybe it's one build pack, one stack pack. If we agree on that, then I'll retool the example and not worry about it. Not worry about this case, or really this case down here. And then we can go on with the rest of the discussion.
It sounds good to me. I don't even think this is necessarily poor design, or like, I think it's okay for us to assume that packages may get installed in the background that aren't during the build process, not before the build process, but
yeah, right. Yeah, that's what I mean by that's what I mean by knobs and levers. Like, if that's the way the Stackpack wants to do its thing, that's fine.
Yeah.
Okay.
Because we already said that we're gonna, sorry, so one last justification for this. We've already said that through the build plan, Stackpacks can make non-mixin changes to the base image as long as they're ABI compatible, right?
Mm-hmm.
That's exactly what installing Google Chrome Stable is when it doesn't report it as a mixin. It's just, it falls into that category of other ABI compatible, but non-mixin contract changes, even though, yes, it could also be reported as a mixin. There's just no way for a build pack to express its dependency on it in that sense, but it doesn't matter after, once the build process is started.
Oh, that makes sense. I also didn't mean to imply it was a bad design. I was just legitimately asking questions.
No, it's
what
great
was possible with the stack driver.
Okay. Before we get back into the discussion we're having, is this related to the open unresolved question about mixins changing on the stack?
I was about to ask that actually. Like, I didn't realize you were going to go down here, but I was just thinking, like our discussion earlier, like if someone installed JQ now and you used to install it, like should we be during rebase making change to the build pack plan that we store for rebase, or should we just pass it to the stack pack and then let it no op itself? Like essentially in that case, when it detects the JQs already installed.
I would keep the logic that says that we can't lose mixins on a base image on rebase for now, and then maybe decide to relax it later. I agree with Emily that it does seem like if we're going to trust the contract, right, we should let you rebase with less as long as you have that star, right, or as long as a stack pack could provide it. But are we going to be able to guarantee that the stack pack actually does provide it during the build process or fail, right? To me, that's.
And I think what you said earlier, Stephen, that it could do something else that's also ABI compatible means that we have to run all stack packs that ran previously. Just because it could have installed JQ didn't mean it also did something else. So I think I don't even think we could ever optimize that away.
Yeah, actually, I think that makes sense. I think I agree with that.
I don't know, but yeah. I feel like if the only thing it provided was a mixin, and the mixin is present when we rebase, we shouldn't have to rerun it.
Yeah, would that be up to the platform who knows the stack packs to be able to like get rid of the build plan and then not have to pass that in? Because in this case, you'd have to know that your apt build pack is safe to be removed from the build plan that had only apt packages in it that are now part of the stack.
What if we allow you to change the mixins as long as the build as long as a stack pack claims that because the mixin provides are static, as long as the stack pack claims that it can provide it, we allow, regardless if it's more or less, we allow the build to proceed, but we always provide the exact same set of mixins to the stack pack as happened on the original build, even if they're present in the base image. That way, if there are additional things that would get installed when the stack pack installs the package, it would still run. It would just be a no op on installing some of those other packages. I would almost like to go the other direction and say, actually, when you can only add mixins in an incoming new rebasable base image if there's no stack pack that can install for safety. I think that would be the safest thing to do, and say you could never remove. But I don't think we have to figure this out here. Like, I think this could be, these decisions could go into the spec PR.
We can come back if we want, but I'm gonna move up to this new section and let's make sure it's what we discussed. So the detect and build phases will be provided with a new input, the stack specific platform directory, instead of a user space platform directory. So it's not actually a new input, it's just a replacing another input. So in this way, the lifecycle can ensure that no environment variables or other platform-specific extensions are coming from other build packs or other sources that may impact the Stackpacks' ability to successfully rebase in the future. The new stack-specific platform directory will require new options for, it'll require that new flags essentially are added to the lifecycle detect and build interfaces. But the detect and build executables will continue to keep the same interface and just simply get different platform DIRs. So down in the specs section changes, I've added stack platform to the detect, the build, the rebase, and the extender. And the extender does not have a normal platform. It just has stack platform.
So for environment variables, having a separate set of environment variables for Stackpacks, if you need them, right? You explicitly say, hey, this is a Stackpack one. It's going to have to, could vary on rebase, and therefore we have to call it out separate. That makes sense to me. Do we feel the same about services? And their services are still in platform, right? This isn't a question about, bindings, exactly.
Yeah.
This isn't a question about whether we spec it as having a separate platform DIR. It's a question about from like the pack CLI UX, right? Would we, or from the recommendation for a platform, would we mount the same bindings in into both separate platform directories? Do we consider that an unsafe operation for rebase?
I think something like pack is already going to have to distinguish between stack and regular environment variables. Also, right now, pack doesn't know where binding should be mounted. I'm pretty sure you have to do it yourself with the volume. So you'd still have to do it yourself.
That makes sense. I think, I guess, regardless of that UX, the recommendation I think what I was getting to is, I think it's okay if bindings vary, or if we use the same set of bindings between Stackpacks and regular build packs, because they represent connections to real services. There's just there's no way we can replay, a previous set of bindings, right?
Are we then saying in this case that it's just up to the platform to provide them in both directories?
Yeah, like if a service is a service that provides you with app packages, right, or that assists you in installing, or provides, or is a license key for installing some software, that's the way we've used services before, or bindings before, then I don't think we need to change anything in this. I just want to call out.
Why is it okay to make it the same for both and not the other way? How do you know what things you need at rebase? I don't know why this is any different from the environment variables.
In the environment variables case, there are environment variables that are intended for regular build packs, right, that would get exposed in the Stackpack environment, that if they changed between build and rebase could cause problems for the Stackpack. So we separated the environment variables out into a different list where hey, if I change these, I really could break rebasing, right? And so that cordons those environment variables off as safe for Stackpacks. For bindings, because bindings don't represent a configuration that could change in the application. They represent.
I don't know if I agree with that. Right? I don't think it's that different. It's something that could change. You could definitely mount in different values in different places, right?
But they represent an external service that even if they don't change, could still change, right?
I feel
Sorry, go ahead.
Well, that's true. Which service you're connecting to matters. And I feel and that could change. And that's a different, more fundamental type of change, right? And I think you want them separate so you know which ones you actually need to bind on rebase and know which build packs are consuming which things. Also, I don't think in the way we've done bindings at this point, have said these always represent an external service. That's generally how they're used, but I'm not sure if that's a hard and fast rule.
Do we
So
have
maybe-
to know that? Could it just be they may be the same? Like, isn't this really a platform complete decision? Like, I'm not sure.
Yeah.
I do think there is some risk there, but I don't think the guidance should be very strong here. But
I agree. I think pack, to some extent could allow, right, for both you to specify what build time bindings you want versus what, I guess, stack pack things you want as far as binding goes. And then I would maybe even go and lean on the other side where the bindings could be applied to the build, right? But they wouldn't be applied or available to Stackpacks, and therefore it wouldn't impact the rebase operation. But I think that would be up to the platform and what those use cases would be.
Seems like we need some language somewhere that describes, they need to be able to be different for sure. And we need some language somewhere that describes the implication of changing the ones on the rebase side, but we probably don't need it in the RFC. Like, it doesn't seem like there's anything that would lead to a change in this from that. Does that seem right?
Are we dead sure that for the first pass, we don't just want to say no platform?
You still might need environment variables, right?
Yeah, so you need them for at least that part of it. I think we talked about that one. It's whether bind mounting should be allowed. And like I said, at least for pack, I would say that initially we wouldn't want to provide that just because of the hairiness or the implications behind it, until we have maybe a better mechanism to at least help or guide that use case. In more controlled environments, maybe that's different. But they might want it, right? Like Google, if everything happens on the Google Cloud platform, then they could obviously do it. And it shouldn't be a violation if they know that they're attaching the exact same thing, for instance.
Does that mean we think as long as we say the platform dir has to be separate, we can defer on what exactly that platform dir looks like in the Stackpack case until later, whether it has bindings, things like that?
yeah, I think so.
Platforms could even choose not to allow stack environment variables
Yeah,
if they really
exactly.
wanted to, right? It could be empty. Okay.
They really want to share with Buildpacks, they can. That's up to them too.
I think I'm satisfied on the platform dir then.
Okay. I think I'm at a loss for what to do next, which might be a good thing.
So there was, there was a discussion we had going back to the build plan mix-in combinations. We remember we deferred one of the first thing we deferred was there were some combinations of mix-ins not being present and build plan entries not being present, and the extend versus build phase that we were undecided on originally. And I don't know if we ever got back to that discussion. I think that was the last thing that I can remember that there might be still more significant open questions about now that we've resolved the platform thing. It's like, should you run I forget, it was like, should you run the build and not the extend sometimes if they have different sets?
Yeah, it's like stage specific identifiers, right? Like if you only need, the stack pack for the run phase, can you, should you skip it in the build phase always, right? And I think, I'm less concerned about the build phase, but if you skipped the because you definitely want to skip run phase. If you don't need anything for run, you definitely don't want to pay that cost. And that was part of the challenge though, but it's a lot easier to understand if like you submit something that needs to be done and then you just blindly run bin build for both phases. But I think that's just too simplistic.
Is it? I was hoping that's where we would land, that like if it passes, it's going to run for both. It just might no op in one of the cases. My hope being that in the future we could make a non-breaking change where it becomes smart enough to just, hey, if there's nothing that's needed for extend, we don't even run the extend phase. But maybe it's optimistic.
I think once the build pack runs as root and can make arbitrary changes, it's going to be very expensive to tell if it didn't do anything.
Not if it didn't do anything. It's to tell if it needs to run. Right?
Yeah. Right. But yeah, our mix-ins, I think what makes it different are just mix-ins in general, just because if the run image doesn't have JQ, but the build image does, then the build image could theoretically skip my build pack, but then I might have more work to do that wasn't related to installing that mix-in. If my only job was to install that mix-in, then it makes sense to, but I don't know if there's a way that we need to specify that my only job is to install mix-ins.
Yeah, another example, the inverse example might be libpq dev, where the run image has libpq, and so you just need to install it and build. Well, no, I guess maybe that's not a good example because you'd have run : build :
So if a normal build pack makes a require, that's a regular require from a stack pack, right? There's no, like currently we have, in like for Picado, we have run equals and build equals in the, require entry that's read by the build pack, and then the build pack can decide if the layer it generates is going to be runtime or build time. For those normal entries here, the entry is going to get sent to both sides of the stack pack, right? And the stack pack is always going to have to process that entry. So as soon as you introduce regular build plan entries into stack packs, I think from what we've currently defined, we force both the build and the run to always run, right? Are we comfortable with that?
There's no stage specific prefixes.
Mm-hmm.
Is that right for normal?
Yeah.
Are we comfortable with that?
I am, because I think it can be the responsibility of the stack pack author to account for that. That does mean that like my hope of changing it backwards compatible over might not be true, because some people might, like I think this is what you're driving at, make changes even if there's no build plan stuff. But yeah, I mean, I think it's simpler for the stack pack author to think about, even though it is something they have to think about, rather than trying to like figure out when it's going to run and when it's not going to run.
So if a stack pack provides a thing that's not a mix-in, then you immediately know that it's going to run in both stages. But that is sorry, those provides are dynamic, right? Yes, during the detect process. So if a stack pack provides a runtime mix-in only and another thing, then the stack pack will still know that it's going to run in both phases, and there's no situation where on a rebase it runs in one phase and not the other phase, right? I think this all works. But I thought there was some combination we hit last time that we ran into a problem.
Well, yeah, I think it's still, if the application requests JQ on the run image and only on the run image, are we saying we're going to run build now? Always, like on the build phase?
I think we're saying no, right?
How do you know to skip that? Is there any way for a build pack to say, I require this mixin to do my job, but my job is not installing mixins? My job is to do some other ABI compatible thing to this stack image. Like in addition to the mixin, right? Or is that just too far-fetched? I don't know.
Sorry, maybe I didn't understand. I think I didn't understand which kind of build pack.
Yeah, so I guess it's kind of like the Chrome driver one,
Yeah.
right? Where someone requests Chrome driver, it doesn't exist on the run stack, but it exists on the build stack. But in addition to doing the Google Chrome stable, I install the Chrome driver. Like I still need to do that at build time, potentially. Even without a requires, like, it's hard to think about, but I think there's something there.
Maybe, but I also feel like kind of like with the Chrome driver example, I feel like there might be enough knobs and levers, and that maybe we're talking about a case where that's just not the right architecture of your Stackpack, Buildpack, and whatever. Like is this another case where splitting those into two different build packs, or like a Stackpack and a build pack solves the problem? Probably. It's hard. I agree with you. It's like I feel like there's a thread to pull on there, but I also feel like the mechanisms are in place to solve 90% of those kind of problems. I think that's really what we're trying to figure out, right? Like, we're not trying to catalog every use case of Stackpacks here. I think we're trying to determine if the abstraction we've created is sufficient and capable of generically solving problems. And I think we're confident it is for the 80%, the app packages and the CA certs and a few other things. I didn't even put the cred helper one that you described, Jesse, because I'm like, it just seems like so straightforward.
Yeah.
I'm not worried about use cases we're missing. I'm worried about edge cases we're not thinking of, with having the two phases running simultaneously with different sets of mixins and then rerunning them later. That's the thing I'm like, makes me keep thinking about it. If we miss things, we can add them later, right? That doesn't bother me. But it's like I'm a little tempted to say, well, should it be Stackpack for now? Should it be Stackpacks can either provide mixins or regular entries, right? And force people to split them until we're sure that we understand all the edge cases for a Stackpack that could do both. But if that's the case, like, is it terrible? Like, if there's some horrible edge case in what we do now, is it that bad if we have to come up with something later to fix it? Maybe it is.
Yeah, I think that's the question. Like, can you skip if no mixins are required? Because can you make that decision confidently for all Stackpacks? Like, is that, and if we can, do we just want to go ahead and like solidify that in the spec somewhere, right? Kind of like a clear in, if you want to be like mixin only somewhere in here.
Can you skip if no mixins are required and there are no regular build entries?
Right. Yeah, exactly.
Yeah. I think so. I think otherwise the app build pack is pretty bad. You wouldn't want to put it somewhere, right? Because it would hurt performance. Is that what the text says right now, Joe?
I didn't follow that.
If a build pack requires run libpq and just that, and you have the app build pack, does the build stage run?
I don't know if we capture this. I know we've talked about it.
Yeah, I'm not sure. We said they can run concurrently, and I think they say they get I don't know if it actually says.
See details below.
Where is that?
It says during the extend phase, stack build packs that pass detection. I guess it's a question of did they pass detection though? I think it might have actually been back up. Sorry. Even further. The platform may compare the list of mixins that are statically required by all build packs with the static list of mixins provided by the stack build packs and fail to build. Oh, I see. No, that's just pre-validation. Oh, and then during the. Oh,
sorry. I kind of think I know where we might want to go, but
go for it. Go for it. I'm sure you're right.
Passes detection. It's very vague.
Yeah.
It doesn't say anything about phase specific that I see.
This is what I thought had it, but I don't think so. I think if we do talk about it,
yeah, okay, there it is.
yeah, this implies here that it's going to run both and it just won't appear, right?
I don't know if
I'm saying that's what the text says. I'm not saying that's what we have to decide on.
Yeah. I just mean I don't know if saying that doesn't show up in the list says what happens when nothing shows up in the list. If that makes sense.
Yeah.
Like, do we have any language that's it says pass, right? If a stack build pack provides a mix and it's not required, the stack build pack may pass detection for each phase if a stack pack for each phase up there at the top on 133, right?
Yeah, none of the mixins are required. It must be skipped. Yeah, 135 is the one that
Yeah. So
says that you would skip build.
Technically, it says for each phase there. There's a different pass. It implies that there's a different pass and fail scenario for build versus extend, and therefore it would be cut in the build one.
Yeah, this maybe isn't quite. I mean, it just talks about mix-ins. It doesn't talk about other requirements, but I guess those are just implied.
It does say it must be skipped, right?
Yeah.
I was wondering about, because I feel like we only skip things right now that are listed as optional true. Do we have a stack pack that just decides whether to pass or fail without putting things in the build plan? I feel like in some ways that's
is optional the gear we need to kind of make this make more sense. Like,
if the order looks like the other order, it would be assumed that there's optional for each build pack in a group.
Aren't stack packs always optional equal true? If a stack pack hard fails exit 1 during detect, do we actually fail the whole build?
No.
So then it's optional true is the only state, right? And then they're extra weird because the mix-ins can actually be partially satisfied. Sorry.
Yeah, no, that's all correct. So I think the case we're worried about is that a stack pack does something, puts something in the image that it needs that isn't captured with either dependencies or mix-ins. And so I think we're worried about two cases. One is where it's not supposed to run, but it runs in one of the stages in either extend or build. And it does something with a side effect that it wasn't supposed to do. Or it kind of needs to run and but it doesn't run. Sorry, I lost myself there. Anyways, I was gonna say, I think, is it possible that the solution is where a build pack provides and requires the same thing to sort of ensure that it always runs? But in this case, can they not? But they can't require mix-ins. But can they require regular?
No, because the order is enforced, right?
Yeah, that's right.
I think. Or wait, did we We may have changed that actually.
They can require things from themselves.
From
right?
other Stackpacks and from
Right.
themselves, I guess. Yeah.
So that a stack pack can definitely enforce that it always runs. What about a stack pack that doesn't have any mix-ins or
It has to run in both. Yeah.
require or provide anything? That always runs.
Wait, no, that wouldn't always run. It doesn't. If it doesn't provide anything at all,
it still passes
it may
detection.
pass.
Yeah,
It may pass. And so it could pass based on something it sees in the app, something it sees in the image, the stack.
Yeah. Yeah, but if it does pass, then it runs in both. That's the important thing, right?
Mm-hmm.
Like passing out detection on the build means you will run during rebase.
The things that will cause a stack pack not to run are a regular build plan entry is not matched, that it provides is not matched. A regular build plan entry that it requires is not matched. Or it provides some mix-ins and no mix-ins are, or it says it can provide some mix-ins and no mix-ins are required.
Right.
This is getting a...
It has to detect fail in that case. Because we're not putting the provides in the build plan, or it detects pass, and then how do you know the difference between that and what if, I know no one likes this idea, what if we just did the mix-ins on the first pass? It's much simpler.
What if we approve as is, but we put a line at the bottom that says we're going to implement the mix-in thing first without the regular build plan entry and then ship it?
Yeah, I will approve this as the vision, but I'd love to get a spec PR that only does the we could do the detect.
I'm comfortable with that.
Yeah.
Yes,
I'm comfortable with that.
I would love that. Sorry.
Yeah. Because so I think that's fine. That makes sense. Like this is not a spec. This is a vision. I think that's a really good way to frame it. I think we can do that.
So real quick, Joe, can you search for requiring mix-ins in here? Because we do have a section that specifically says requiring is what it says. Yeah, it says a stack build pack may not require any entries in the build plan.
Neither mix-ins or non-mix-ins. Who wrote this? Anyways, I think that's fine. That was I was just considering it as a mechanism. I'm definitely leaning towards if it passes detection, it runs in both phases. But I kind of don't like this idea of it passes detection and then it maybe runs in one of those. And it's almost, it's not non-deterministic, but it's hard to figure out which phase or phases it's going to run in. And I think as a Stackpack author, that's harder to think about than it's going to run, and I need to account for that potentially with the forthcoming stack type environment variable.
I don't like the idea of if you make an apt build pack and something says I need this package in the runtime image, that a layer gets generated, or needs this package in the build time image, that a runtime layer gets generated, because then it goes. Sorry, maybe I misunderstood what you meant.
Yeah, it would not. So let's say there's two cases. One is that the stack already provides it. Let's say this. Let's say the run stack has libpq and the build stack does not. And there is a build pack that requires libpq. That app package, the apt stack pack is going to pass detection. And then in the build phase, it's going to run because there's no mix-in. And in the run phase, it's going to run, but it has to be smart enough not to reinstall it, I guess.
But if you run the run phase If you run you mean the extend phase, right? If you run
the extend phase, but no, it's not going to get it it's not going to get it in the build plan, so it's not going to install it. So it won't do anything.
But the build pack will still execute in the extend phase,
yes.
Which means that we don't know what else could have happened. We have to snapshot a layer, right? And then on rebase, we have to replay the build pack.
But that layer should be empty if the stack pack is written correctly. That tarball should be empty, and we can just chuck it, right?
Yeah, we currently don't throw out empty layers, but
we can do that though.
But we could. What I would like, which is similar but maybe slightly different, because I've wanted this in other cases for regular build packs, is a way for a build pack to return an exit code. That means I'm not doing anything.
No, yeah. I think could we improve, like we just said, where it runs in both places to simplify things, and then come back around with an option to be able to like have build packs have more granular control on whether they run in both phases, and like potentially exiting with the status code or predefining that it needs to skip.
If we just start with mix-ins in the implementation, right, then it's safe to skip the phases if they don't have any mix-ins. And so I recommend we leave it as an unresolved question for once we've implemented the build plan entries. But initially we implement it so that the only things that run are the phases where the mix-ins are needed, if that makes sense. That would make me comfortable. And then we can decide later if we need to run it in both phases and chuck empty layers, which scares the crap out of me per reasons, but or over time. With that, I'm ready to approve. Does anybody feel uncomfortable about saying this is good enough to proceed to spec PR and implementation? Maybe we're there almost.
Believe it when I see it.
Yeah.
I feel good about it. Let's ship it.
Yeah.
I feel much better about the idea that we'll do the mix-in stuff first, which makes me fine approving other things I'm less sure about, because I think as we do that and get this framework for running Stackpacks, it'll be easier to think about all these other questions that we're laying on top.
Really good job. Thanks, everybody. That's
okay.
Great.
See you.
Bye, everybody. Take a look at this one last time and vote if you can. Bye.